Hello, today in this video we will do homework 58. Okay, 58. Consider the three connected objects shown in figure 58. In this inclined plane is the frictionless and the system is in equilibrium. And find the mass big M and the tension T1, T2 if the value of M is doubled the value found in part A. Find the acceleration of the object under the tension T1, T2 if the constant of static friction between M and the 2M is in the plane is U and the system is equilibrium. Find the minimum value of big M and the maximum value of big M. Compare the values of T2 when big M has its minimum and maximum values. Okay, this is our picture. We have the big M like sphere and the M1 and the M2 like this. Okay. This is M1 and the big M, and then we have the one. We have the M and the 2M. Okay, and then we have the angle alpha, and we need to find the in the first A task. We need to find the mass of big M and the T1, T2. If this is frictionless and A this will be 0. Okay. We need to draw first M and we have the MG. I'm drawing this part, first part. Okay, first part, and we have the tension to the up, and this will be tension 2. Okay, and we have the acceleration. Okay, and the second part is I will draw this small m. This is small m, and then this is mg. Okay, but we need to draw this mg cosine alpha, and this is mg. This is mg sinus alpha, and we have the friction force like F1, and we have normal, but this is not important, and we have the tension too. Okay, the third part is I will draw the 2 M's direct of forces. M. Also 2 mg cosine alpha, and in this direction 2mg sinus alpha, and then also we have it have friction force, friction 2, and then the normal, and the tension. This will be tension first tension 1. Okay, we have I have drawn the whole part, and we need to find the first a mass of M, and the B we need to find T1 and T2 and T1. Okay, T2 is equal to mg minus ma. This is the first Newton's law, and the second part will be okay. I'm forget this part. This will be T1, and the T1 and the T2 is opposite, and we need to draw T2 minus T1 is equal to mg sinus alpha. Okay, and we have the T1 is equal to 2mg sinus alpha. Okay, this is basic tensions, and then I need to find the first big M. We need to T2 is equal to mg because we have that acceleration, and this also is equal to the T1 plus mg sinus alpha, and the T1 is also equal to 2mg sinus alpha, and this will be 3 mg sinus alpha, and the big M is equal to will be 3 m sinus alpha. Okay, next question. In this C question, this big M is doubled, and we need to write the T1 and the T2. Okay, this M2M is equal to the 6 small m sinus alpha. But in this case, we need to find acceleration. Okay, we have acceleration, and we need to write tension like this. Tension 1 is equal to 2 mg to m, and the g is in this case 2m since alpha. We need to do the plus because it's to the upward, and the t is will be 6 m g sinus alpha. No, 2m 6mg 2m sinus alpha minus g minus a, because it's a to the downward is attention to, and okay, to the right, and find a acceleration, and this acceleration will be a sinus alpha, because this is small m's, and the one divided by 1 plus 2 sinus alpha. This is the second. Okay, this is our acceleration, and we just put to this part tension 1, tension 2. Okay, tension 1 is equal to the 4 mg, because this m doubled 2 mg sinus alpha, and we have to the right to this with multiply, and the to tension 2 is also like this, but we have the 6 mg and sinus alpha. Okay, and next question is in this equilibrium we need to find the m minimum and the m max. Okay, m minimum will be like this. If this mass will be minimum, and these two parts will be goes to the down, and the friction will be like to this part. Okay, and if this m will be max, and these two block are goes to the up, and the friction force will be opposite side to the down. Okay, we need to just find the for F1 friction 1 will be 2 mg, 2 is 3 mg, and sinus alpha, not sinus, this is normal force, and the normal force will be cosine alpha, and the second friction force will be umg cosine alpha. Okay, we need to find the minimum mass. This minimum mass will be T1 is equal to the mg. T1 is equal to the 2 mg, but sinus alpha like this, 2 mg sinus alpha, but we need to the right minus u cosine alpha, because we have the friction, and this 2 energy sinus alpha is will be to the downward, to the downward, and the friction force is will be goes to the upward. Okay, this is T1, and we need to write 2T is equal to mg in this bracket sinus alpha minus u cosine alpha. Oh, this will be 6 T2 minus T1 is equal to this, and this T2, we know that T2 is will be the T1 plus mg, and this two part we need to the plus, and T2 will be 3 mg sinus alpha minus u cosine alpha. And we know that T2 is equal to big mg, and this big mg is a minimum like this 3 small m, and in this bracket sinus alpha minus u cosine alpha. Okay, this is the minimum mass of big M, and we need to find the maximum mass of big M. We need, if the sphere is maximum big mass, and this will be like to this, blocks will be goes to up, and the friction is will be to the downward, and the maximum part like this is the minimum part, but we need to the write 3m sinus alpha, we just plus this sinus alpha plus u cosine alpha. Okay, this is the big mass, and this is minus minimum max and minimum. And the last question was the T2 max minus T2 minimum. Okay, and this is the max minimum T2, and the maximum T will be just this. In this part we need to get the plus, and if we this will compare will be just this part, and I want to find the with mathematical fraction, and I just the plus. In this case, the minimum in this minus will be plus, and this 2 cosine u cosine x will be get to the added, and just 6 small m g, and the sinus alpha, and no, not sinus alpha. Okay, is equal to 6 UMG cosine alpha. Okay, this is the last answer.